Hello and welcome to the DipDup tutorial by backend. My name is Michael and I will guide you through 9 steps of creating a custom backend for your Tezos decentralized application, and I will show how to use it on the client side. But first of all, what is DipDup? When you are building a decentralized application, you typically start with creating a smart contract that encapsulates the business logic. Then you need a website that can be used to interact with the contract, and also an API for querying blockchain data is required for sure. In some cases, it's enough to just rely on standard Node RPC, but mostly it's not that efficient. There are projects providing indexed blockchain data, which is much more convenient to use. However, you are still working with low-level entities such as blocks, aberrations, and so on. DipDup is the concept and set of libraries that allows you to stay within your application domain, meaning that you operate with application-specific entities instead. To sum up, DipDup is a framework reducing boilerplate code and facilitating best indexing practices, which is a huge time saver. And for those who are from the Ethereum world, this is very close to the Graph protocol. In this tutorial, we're assuming there is already a deployed smart contract. And as an example, we will take a DEX contract, specifically a KeepSwap instance for the Plenty token. Anyways, let's go step by step from the very beginning and build a backend, an SDK, and a minimal demo interface for this particular case. First, let's create a new folder for the project and step in. Let's check that you have Python installed and not installed. This is very important. And we will also require Poetry, which is an advanced package manager for Python. It's roughly the Yarn equivalent in the Python world. And we will create a new project using the interactive wizard that Poetry provides. Now that we will install DipDup as a dependency at that step, it's okay if you skip that. At that stage, you will also always will be able to do that later. Anyways, that will take some time. Meanwhile, there are common mistakes with installing Python on your system, especially if you have an old system when typically you have 2 versions of Python. And I recommend to use PyEnv to manage your Python versions. That way, you will never have like a conflicts between different versions. It won't be necessary to specify which version you want to use right now. Okay, so right now, Poetry installing all of the dependency, including DipDup library. And we're good to go. So now we're creating a virtual environment and checking that DipDup is installed correctly. Every new DipDup project starts with a configuration file. And now we will write it section by section using the documentation provided on the dipdup.net. So first of all, we need to specify the version of the configuration file we will use and the package name that will be required for importing all the modules afterwards. Then we specify the database backend we will use, and for debugging purposes, the simplest possible case is SQLite engine. Then we need to define the contracts that will be used later, and we need to specify the address for the KeepSwap DEX contract that we will use. And in order to do that, we can use better call Dev Explorer to find and copy the address of the target contract. We also have to specify the type name, which will be required for call generation later. Also, we need to specify the data source, basically the API that we will use to fetch all the blockchain data, and we will use tzkt API for that. Lastly, we are describing the rules of how DipDup should process the blockchain data and fill in our application-specific models. We tell DipDup that this is the operation index, meaning that we will index operations, and we need all the operations related to this particular contract, keep us for plenty, and that we will use tzkt data source. And since it's DEX, it has two entry points for buying and selling tokens for Tez. And now we need to define handlers for both those entry points. First, we will define Tez to token handler, and we need to specify the matching pattern for the operations called during the invocation of this entry point. It's very similar to how regular expression works, but more simple. And in this case, we will also require another contract, which is plenty token itself. We need to define it under the contract section so that we can use it in the pattern. And we say that we also want to match the transfer call to the plenty token contract in a single operation. Okay, and now we're defining a handler for the token to Tez entry point. And there are now three calls. First one is the token to Tez payment invocation of the KeeperSwap contract, then a transfer of the plenty token, and lastly, there is also a third transaction that goes to the source of the operation group. We also need to specify that in the pattern so that we can match the exact amount of Tez that the sender will receive. Now we're ready to do code generation. Based on the provided configuration file, DipDup is able to create the entire package structure, namely the file that will keep all the application-specific models, then all the types for the contracts specified in the configuration. Remember the type name that I mentioned before. And finally, handler stubs that are to be implemented by the developer. In our case, those are Tez to token and token to Tez handlers, respectively. And we will start with filling in the models. And in our case, since we are indexing a DEX contract, naturally we will have trades. And we will consider each call to the DEX contract actually either Tez to token or token to Tez as a new trade. Each trade has a unique field ID, which is just simply an integer that will be incremented for each subsequent trade. For each trade, we will have a trader, which is actually an initiator of the call that causes that particular trade. We specify maximum length for this field as 36, which is the length of the address in Tezos network. And next, we will have trade side, either buy or sell. So if we have Tez to token, that means buy, because we are given away Tez and receive tokens. And if it's token to Tez, that's sell. Sure, and in that case, we use enumeration to describe that. Moving on to the next field, and we need to specify the amount of Tez that we either give away or receive in the result of the operation. And since that's an amount in Tez, we will have a decimal field with 6 decimals after the dot, and let's say 16 digits total. And also we specify the amount of tokens that we are either buying or selling. For the plenty token, it's 18 decimals. We can check that on the Vertical Web Explorer on the tokens tab. That's the field in the token metadata. And let's say like 32 digits total. That should be enough. Like naturally, we will also require trade price, which is basically Tez quantity divided by token quantity, and it's also in Tez, so we are having 6 decimal places, and let's take 32 digits in total as well. What else? What else should we add? So, like naturally, we have the block level when this operation was included into the chain, and also timestamp, which is a time mark for this particular operation. In addition to the trade model, let's also have a dedicated model for our trader to keep some stats about a particular account. Each trader model will have a unique address, essentially, which is also 36 symbols maximum, and we specify that this is a primary key. We will keep track of the amount of trades per each account and the total volume of trades per each account as well. That way, we will be able to show some personal stats on the traders page, for instance. So it's kind of the minimum information that we can show for a particular account. Now that for trades count, we are using big integer field. And for trades amount, we will use decimal field because this amount is in Tez. So we are using 6 decimal places and 32 digits in total. Also, now we have to add a relation between those two models. And we need to change the type of the trader field in the trade model to foreign key field. So that way we are setting up the relation between those two models. Once we have models described, we can switch to implementing the handlers. And roughly what we have to do is to convert a group of operations to trade. And like there are two cases. Like first case is when we are buying tokens for Tez, and vice versa. So basically we need 3 things. First of all, the address of the initiator of the call chain, basically the trader, right? Also, we need the amount of Tez spent and the amount of tokens received by the trader in the result of the operation group. And that's basically it. So we can get the trader address from the first operation, which is test token payment invocation. We also can get the amount of Tez from that operation. And as for the amount of tokens, we can extract that from the transfer parameters. That's the reason we included transfer call to the handler pattern back then when we specified the index in the configuration file. Meanwhile, you might notice that in Visual Studio Code, the auto-completion for Python is not working very well, specifically for the library we use for generated types, which is called pedantic. That's why I highly recommend you to use PyCharm Studio from JetBrains, which is like built specifically for Python, and they have much more better support for Python and for pedantic library. And like especially that's like better experience when you are working with type models, because in Visual Studio Code you have to look into the types to see which fields are available, which is like not very convenient. Anyways, we have all the information required to create a new trade. So we can calculate the price. We can get the level from the operation as well. And we can get the timestamp also. Note that in operation, timestamp is in the string form, and in our model we have a date time field, but the conversion is happening automatically, so you don't have to worry about that. Also, besides the new trade, we also have to update the stats for this particular trader. So first of all, we need to check if this trader already exists in the database, right? And if it's not, we need to create a new one. And finally, we need to update, well, basically increment the number of trades for this particular trader and the total amount of trades using the test quantity we have extracted from the operation. The second case is pretty much the same as the first one. The only difference is that now we have to extract the amount of tests received from the third operation, which is a simple transaction without entry point or parameters. Besides that, all other fields are calculated the same. But yeah, another difference is that we now have sell, trade side sell, while in the first case we had trade side buy. You may say that there is an opportunity for refactoring. We can extract common code parts in a single place, and that's true. Just in this video, I'm trying to do everything as explicit as possible. But like in real application, you can do that for sure, and you like should do that for sure. Now, when we have our models described and handlers implemented, we can run our indexer finally and see if we did everything correctly. And it seems that we did not. There is an error, and now we will see which one it is. And it seems that there are some issues with the models, and yeah, that's the first of all, we did the call incorrectly, and the second error is that there wasn't a default value for the trade amount field. Yep, now everything should work smoothly. And we should see that operations are processed one by one. The logs, nope. Again, there is something wrong with the indexer. Okay, yeah. Now we have an error with extracting test amount from the operation. Yep. There's no need to access data field because there isn't one. So hopefully this is the last one and everything will run smoothly. Okay, it seems that like everything is okay. So our indexer is processing operations one by one, and it's filling the database with trades and updates trader stats. We can see what's inside the database using an SQLite extension for Visual Studio Code. Just install that and type SQLite in the command line palette. You will see the SQLite tab next to the file explorer. Yeah, our database file is detected, and we can see that there are some trades. There are many trades with all the fields that we can have specified, and there are traders with some non-empty stats. So everything looks fine. Looks that we have done everything correctly. As you can understand, this is a not proper setup for production, even for testing actually, because there is no way to access the data inside the database. Right, so now we will try something more complicated based on Postgres as database backend and Hasura as API engine. And we will do that using Docker. You can visit the dedicated article in the documentation of how to write a Docker file and Docker Compose configuration. And basically, since this is a Python application, all you need to do is to install requirements, all the dependencies required, and just do DipDup run as an entry point. As for the Docker Compose configuration, we have three services, our indexer and database, which is Postgres, and Hasura GraphQL engine. In order to make all these services work together, we need to configure them. And you can do that through the DipDup configuration file, which is kind of convenient because you have all the configuration in a single file. And so we replace SQLite with Postgres in the database section. And in Hasura, we specify the endpoint and some settings that you can check in the reference afterwards. So now we will try to build the images and run the entire setup. I'm using a very cool utility called LazyDocker to monitor my containers. And we see that everything went smoothly. Operations are processed one by one. So everything seems okay. We have our setup working. So now you have GraphQL endpoints exposed. And in order to learn how to use them, we will check out a built-in playground that Hasura provides. In order to do so, we need to enable the flag that turns this playground on. And After that, we are able to access the playground through the browser. So what you can do using this interface, you can check the schema, like the resulting GraphQL schema that Hasura has built out from the initial models we described. And you can try to make a query using a neat tool, GraphQL Explorer on the left. Very convenient. So, and we can see that there are some traits that we can access through this endpoint, which is great. So at this point, you can stop and just use plain GraphQL queries or any client-side library available in the GraphQL ecosystem like Apollo or others. Or we can go further and use a very cool tool that allows to automatically generate a fully typed SDK out from the GraphQL endpoint. And that's what we are going to do in this video. So what we need is just a simple package.json file with very basic fields and a single script with a simple command that will generate a library, like a ready-to-use library, just using the endpoint that we have created with Docker Compose setup. So we're stepping in this folder and installing all the dependencies required, and finally running the build script. And what we have in the result is a ready-to-use package that we can upload to Node package manager side and like use in the client-side application. In this final step, I will create a very simple view application that demonstrates how you can use the SDK we generated on the previous stage. Most things will be front-end basics, so I won't comment on that. A few things that I should mention though. First of all, we are cross-linking two packages locally, so it's not hard, just need to be done carefully. And secondly, I'm using Vue 2 with the new composition API, which can be unusual for you, but it's like more explicit, and I like it very much. This is the place where we are creating an instance of the client to interact with our API. Now that we are specifying an WebSocket endpoint, which is basically the same as the HTTP one, but the scheme is WebSocket instead of HTTP. And now we can use this client to make both queries and subscribe to updates. An important thing that you should know about updates in Hasura, that's it's actually live queries, meaning that you will receive all the results based on your filters in the past, and then you will continue receiving all the updates that are satisfying your filters. So in our case, we will query all the trades since last five minutes, and we want to get all the columns. This can be achieved using this nice shortcut, everything. And this library is based on the Gen observable class, so we need to provide a callback that will be fired each time there is an update waiting for us. So we are actually converting this observable pattern to the reactive variable in our view application, and all we have to do is to make a very simple component where we will bind to the array of traits that will be automatically updated when there is new item. Okay, so I think we're good to go. So now we will try to build and run our view application and see if everything works as we thought. Yeah, so you can see two trades that happened in the past, and if we did everything correctly, we will see new ones coming with a new log. So in the browser console, you can see that we have established a connection, the WebSocket connection with the Hasura, and we have sent a subscription request with all the information attached, and we received a response with all the past results that are matching this query. And now we are waiting for the next block, because so when like data is updated like once a minute, and yeah, here it is, and we see that there are new trades, so everything works. That's it for this time. Thank you so much for watching and listening. Hope that now you have a rough idea how to build a full stack application on top of Tezos. All the materials are available on our GitHub, and you're also very welcome in our Discord channel, where you can get support for DipDup and for other projects and libraries that we maintain. Good luck, and see you in next tutorials.